Hi, this is John Linneball, and this is Solving Quadratic Equations. Here's my contact information if you would like to contact me. What's a quadratic equation? Well, I'm glad you asked. A quadratic equation is a second-degree equation. That is one where the highest degree of a variable is 2. So something like this here, where y equals x squared plus 2x plus 1. So it's a second degree because the highest degree of x is 2. That's usually the highest degree equation that you'll see on the SAT, with the possible exception of some third degree equations you may have to factor by grouping, etc. That doesn't excuse you from knowing how to do third degree equations you may see on the SAT, but we're not going to cover those here. We're just doing quadratic equations. The most common solution method is factoring. Most quadratic equations you run across in math books and the SAT can be solved by factoring. If a quadratic equation can be factored, many cannot, you can convert it from the form ax squared plus bx plus c to ex plus f in parentheses times gx plus h in parentheses, where a, b, c, e, f, g, and h are constants. That's called factoring the equation. And yes, I know I skipped d. Sue me if you don't like it. Alright, so we can see from FOIL, first, outer, inner, last, probably how most of you learned how to multiply binomials. I know some of you learned the super diamond method. I'm going to use FOIL because I'm the most familiar with that. We can see that e times g is equal to a. Why? Because we have e times g, and that gives you ax squared, so e times g is equal to a. We can also see that EH plus FG, so EH would come from the outer, EX times H, FG, okay, so that has to be equal to B. Why? Because here we get EHX, right? EHX and FGX. And if this cursor looks like it's a little out of control, I'm sorry, but I'm having a little trouble seeing it right now, so I have to play around with it to get it where I want it to go sometimes. So anyway, we can see that EHX plus FGX is equal to BX, which means EH plus FG is equal to B. And then HF is equal to C, as we can see, no pun intended. Anyway, we have F times H has to be equal to C. So you can see that that's L, that's the last part of FOIL. So H and F should multiply to C, where E and G are both 1. Otherwise, it's just EF plus GH equals B. So how does that help? Well, okay, let's say we have x squared plus 6x plus 9. Have that right here. All you have to do is find two factors of 9. Probably should think either 1 and 9 or 3 and 3 that add up to 6. Once you do that, it's a dead giveaway. It's got to be 2 3s, right? So we can pretty easily see that both numbers are 3, so it factors to x plus 3 times x plus 3, which is x plus 3 squared. If you set that equal to 0, then the solution is going to be x equals negative 3, and the reason that is because negative 3 plus 3 is 0, and 0 times anything is 0. So it doesn't matter since they're both the same thing. Once you add negative 3 to 3, you get 0. It doesn't even matter what the other term is, it's going to be 0. Since they're the same, it becomes 0 times 0. So it's still 0. Alright. More factoring, yay! Alright. Factor 6x squared minus 5x minus 6. First, let's set it equal to 0. The equation is in the form ax squared plus bx plus c, and a and c are 6, as we see here. There's a, there's 6, and negative 6 respectively. So the most likely factors of 6 are 3 and 2. So let's try for those coefficients of x and the constants at the end. Since c equals negative 6, one constant is positive and one is negative, because to get a negative product, that means one factor has to be positive and one has to be negative, right? Okay, so let's try 3x minus 3 times 2x plus 2. Well, we use FOIL. Okay, we get 6x squared, 3x times 2x, so far so good. And then we get 3x times 2, that's 6x, yeah, alright. And then negative 3x times 2x, ooh, that gives us negative 6, and then negative 3 times 2 is negative 6. Trouble is 6x minus 6x is 0, so we just end up with 6x squared minus 6, and what we're looking for is 6x squared minus 5x minus 6. Alright, so let's move things around. Let's try 3x plus 2 times 2x plus 3. Alright. Well, 3x times 2x is 6x squared. Outer. Okay, 3x times negative 3 is negative 9x. And then 2 times 2x is going to be 4x. Okay, well, negative 9x plus 4x is negative 5x. And then, of course, 2 times negative 3 is still negative 6. So we're good. We got 6x squared minus 5x minus 6, which is what we started with up here. So we know from checking our answer using FOIL that that's the correct way to factor it. The quadratic formula. This is the liquid plumber of quadratic equation solutions. Notice I spelled plumber properly, so it's not the copyrighted or whatever, the trademarked, the trademark that is used by whatever chemical company owns the rights to the consumer product that I'm certainly not talking about. Anyway, yeah, this works for any quadratic equation, whether or not it can be factored. So for any equation where ax squared plus bx plus c equals 0, the solutions to that equation are x equals negative b plus or minus the square root of b squared minus 4ac over 2a. This is something you should memorize for the SAT or the ACT. Neither exam will give this to you on any formula sheet. The ACT, if you need to use it, they're probably not going to give you that formula. They do give you some formulas and questions where they just want you to plug in the numbers to see if you can do that correctly, but this is not going to be one of the ones they give you. So please, please, please memorize this. I know some of you have learned a little song from your math teacher. Great, memorize the song, or just do as I did and just memorize the thing. I know it's awful, but do it, you'll need it. Okay, the quadratic formula, why should you memorize it? Well, one, it works for factorable equations. So that way you don't even have to figure out if it can be factored, you can just plug it into that. Boom, you're done. So let's take x squared plus 6 plus 9 equals 0. So we just did this problem a little while ago, so we know from doing it earlier that this equation factors to x plus 3 times x plus 3, and the solution is x equals minus 3. So here, we know that, well, let's assume basically that we hadn't done that. Okay, we know a is equal to 1, because there's nothing in front of the x squared, so it's an implied 1. B is 6, C is 9. So negative B equals negative 6, and B squared equals 36. 4AC, okay, that's going to be 4 times 1 times 9, so that's 36, and 2A is just equal to 2, because A is 1. So then we just end up with negative 6 right here, plus or minus the square root of 36 minus 36. Alright, that's pretty easy, so that just ends up being 36 minus 36 is 0, so obviously the discriminant is 0, which we'll discuss in a minute. Anyway, the discriminant is this thingy here. It's 0, so we end up with negative 6 over 2, so it's just negative 3. So you can say that where b squared minus 4ac equals 0, there are 2 equal roots, or only 1 root, depending on how you look at it. And that's basically, well, that's nice. I mean, it means you have 2 equal roots. Anyway. B squared minus 4ac is called the discriminant, probably because it allows you to discriminate, that is, to tell the difference between different kinds of solutions. If the discriminant is positive, there are 2 different roots, and they're real roots. If it's negative, the roots are imaginary, or it has, in quotes, no real roots. So the discriminant is a useful thing to keep track of. That's b squared minus 4ac. It works for non-factorable equations. Okay, so let's say we have 3x squared minus 2x minus 6 equals 0. So again, we can see that a is equal to 3, b is equal to negative 2, and c is equal to negative 6. So negative b is equal to 2, because negative 2 would just be 2. And b squared, of course, is equal to 4. 4ac is going to be equal to 72, because it's going to be 4 times 3 is 12, times negative 6, that's negative 72. And 2a, of course, is 6. So then when you plug it in, okay, negative b, it's 2. B squared is 4, so it's 4 minus 72 over 6. Okay, so 2 over 6, we can break that up into a different part of the fraction. We're into just a different number, so we end up with 1/3, that's this 2 over 6, plus or minus square root of 76 over 6, equals 1/3 plus or minus square root of 76 over 6. Okay, you can factor a 4 out of 76. 76 is equal to 4 times 19. So then you just end up with 2 root 19. And in case you don't believe me, not a problem. I'll get the calculator out. Okay, calculator. We can divide 76 by 4 and you get 19. Okay. Since we know that the square root of 4 is 2, then that just ends up being 2 square root of 19. Since it's 2 square root of 19 over 2, I know there should be parentheses here since I'm writing it out like this, but there's not, so just know that the 2 and the radical 19 are on the top. These 2's, of course, on the top and the bottom cancel out, become 1. So you just ends up with equals 1/3 plus or minus 19. I also apologize for the extra equal sign. That's no special mathematical thing. That's just me making a typo. Sorry about that. Alright, so on to the next thing. It works for problems that only have imaginary solutions. So if the discriminant, that is again b squared minus 4ac, is negative, there are no real solutions, but there are imaginary solutions. Why? Well, because you take the square root of the discriminant in the quadratic formula. So when you take the square root of a negative number, it's by definition an imaginary number. The square root of any negative number is just going to be the square root of the positive number, the positive counterpart to it, times I. So the square root of -3 is going to be I times the square root of 3. I, of course, is the imaginary unit, which is the square root of -1. So we can tell that where 3x squared plus 2x plus 6 equals 0, b minus 4ac is going to be equal to 4, so that's 2 squared, minus 72. Okay, again, it's 4 times 3 is 12, times 6 is going to be 72, and since it's minus 4ac, it's 4 minus 72, which is -68. The discriminant is definitely negative, and the roots are both imaginary. It's -2 plus or minus square root of -68 over 6. So then, again, -68 is 4, -4 times 17, if you will, or it's just going to be, 4 times -17. So the square root of 4 is 2, so we end up with -1/3, because it's -2 over 6 is this part, and then 2 times -17. 2 times the square root of -17 over 6. 2 over 6 is 1/3. So then you can factor out the 1/3. So it's going to be 1/3 times -1 plus or minus I root 17. I, of course, again, is the imaginary unit. If you don't understand that about imaginary numbers, please, please, please watch my video about imaginary numbers, and please also just study that in your SAT book or your regular math book. It's important to understand what imaginary numbers are. Note, make sure that the equation is equal to 0. When you try to use the quadratic formula, one nasty SAT trick is that they'll set the equation ax squared plus bx plus c, but it's not equal to 0. It might be equal to 3, it might be equal to 4, or some other number. So then if you end up with x squared plus 6x plus 9 equals 3, someone who's not paying attention will just plug 1, 6, and 9 in for a, b, and c. That will not give you the right answer. You'd have to subtract 3 from each side before the quadratic formula will work. So here you'd have to have x squared plus 6x plus 6 equals 0. Make sure that you know a is the coefficient of x squared, b is the coefficient of x, and c is the constant. They could give you the problem in the wrong order, so they could give you x squared plus 9 plus 6x equals 0, in which case you'd have to rearrange the equation before you plug the numbers into the equation. I mean, it'd be easy enough to just go x squared plus 6x plus 9 equals 0. Or you might accidentally use 9 as the value of b, or 6 as the value of c, or probably both. If you do one, you're probably also going to do the other. And again, as I said in South Park, you're not going to have a good time. You'll get the wrong answer, and then you'll be sad. So, also, don't switch the negative and positive signs accidentally. So, let's say b is equal to -2, then of course you're taking negative b in the equation. it's negative b plus or minus the square root of b squared minus 4ac. Make sure you put 2 for b, for negative b rather, not negative 2. Yes, I did that the first time I solved the problem. It's one of the problems we just did. I think it's actually the second from the problem that we just did. Anyway, don't. Where there's an answer, where there's a negative sign, where there shouldn't be, a lot of times it'll be that leading term that's going to be, you know, say negative 2 over 2 or 2 over 2, you know, which becomes 1. So one way you get negative 1, the other way you get 1. If there's a negative sign where 1 shouldn't be, or vice versa, where it's positive when it should be negative, that will be one of the wrong answers because they know it's a really easy mistake to make. Is that really fair when you basically understand it? I don't know, but that's the way it works. So here we go. Completing the square. Just as the quadratic formula, this can be used to solve any quadratic equation. Most people don't like this method, but it's a really effective way to answer questions about circles and coordinate geometry. It's called completing the square because you add, subtract, whatever until you have a perfect square. That's going to be something in the form of x plus b squared, where b is a constant. Of course, x is our variable. Probably an integer on one side, and some, you know, this is probably an integer b, and some constant on the other side of an equation. It doesn't have to be, b could be a fraction, b could be a decimal, but most likely on these tests it's going to be either, you know, an integer, or it'll be a really simple fraction, you know, probably one that's easy enough to take the square root of, etc., like, you know, 2 over 4 or something like that, you know, 1/2. Well, actually, that one wouldn't be that good. Okay, fine, whatever, it'd be 9 over 4, which you could take the square root of and get 3/2. All right. So here's an example of completing the square. It's 3x squared plus 12x plus 3 equals 0. So starting with that equation, first thing we're going to do is divide by the coefficient of x squared, which we know is a, which is 3 here. So, okay, 3 over 3 is 1. 12 over 3 is 4, so we can see x squared, that's 1x squared, right? 12 over 3 is 4, and 3 over 3 is still 1. So we get x squared plus 4x plus 1 equals 0. The second step, we're going to remove the new constant term. Well, that's 1 here, and that's equal to c over a, because remember it's 3 divided by 3, which is 1 from each side. So we get x squared plus 4x equals negative 1. The third step is we take half the coefficient of x, b, which is 4 here, square it and add it to each side. Half of 4 is 2, and 2 squared is 4. So we add 4 to each side, and we get x squared plus 4x plus 4 equals 3. It makes sense since the equal constants in the perfect square have to add up to the coefficient of x. Since they're equal, it means they have to be, each one has to be half, so we know it's going to be 4 divided by 2, which is 2. And the square has to be equal to the constant, c, which is, again, 4. So we know that the square root of 4 is 2, so this has to be basically x squared plus 4x plus 4 equals 3 has to factor to x squared plus 2, since we know 2 is half of 4, 2 squared is also 4, and the 3 we just leave alone, so we get x plus 2 squared equals 3. You can also write it out as x plus 2 times x plus 2 equals 3, whatever makes you happy. Alright, so the fifth step is to take the square root of each side. So if you have x plus 2 squared, you just remove the parentheses and the squared symbol. If you wrote it out as x plus 2 times x plus 2, just cross one out. And it's going to be equal to plus or minus negative 3. Remember, the square root can be positive or negative, even though the square root symbol means the positive square root. Just if you have a number that when you square it gives you 3, just remember it could be square root of 3, it could also be negative square root of 3. And the sixth step is you just solve the equation x equals negative 2 plus or minus square root of 3, and you're done. The SAT, if it's multiple choice, they might write it out as negative 2 plus square root of 3 or negative 2 minus square root of 3. They might do something tricky like tell me what the positive answer is or something like that. Well, actually neither one of these would be positive, so whatever. But if there's one positive, one negative, possibly they could ask that. They might also say just what are the roots, and you say the roots are negative 2 plus square root of 3 and negative 2 minus square root of 3. Any of those things might show up on the SAT. You can use the quadratic formula to get the same answer. So if you did 3x squared plus 12x plus 3, a equals 3, b equals 12, c equals 3, notice you could factor out the 3 if you wanted to, but you don't even have to if you just plug it in your calculator. Go negative b equals negative 12, b squared is 144, negative 4ac is negative 36, 2a equals 6. So since we've already figured out negative 4ac is negative, we just take 144 and subtract 36 from it to get 108. So square root of 144, minus 36 is square root of 108. And then since we're dividing negative 12 by 6, that just becomes negative 2 plus or minus square root of 108 over 6. And so it's negative 2 plus or minus. We can factor 108. It's going to be 9 times 4 is 36, times 3 is 108. So it's the square root of 9, square root of 4, square root of 3, which of course is going to be just 3 is the square root of 9, 2 is the square root of 4, square root of 3 is still square root of 3. So you just end up 3 times 2, of course, is 6, divided by 6. So 2 plus or minus square root of 3, or negative 2, I should say, plus or minus square root of 3. So same answer. As I said before, make sure you watch out for those pesky negative signs and make sure you've got them right. It's not a bad idea to check your answers from completing the square using the quadratic formula, since for most people, quadratic formula is easier because they use it more. That's certainly where I fall. And you could do it the other way. You could also check your quadratic formula answer by completing the square if you're happy with that. If your answers don't match, then you know you did something wrong, so it's always a good idea to check your work, even if you just check it using the same method, because one negative sign turns a right answer into a wrong answer, for example. Coordinate circle example. The equation of a circle whose center is at point h, k with radius r. So we're talking about Cartesian coordinates, the xy plane, all that, with radius r, also in coordinate units, is x minus h squared plus y minus k squared is equal to the square root of r. So it's easy to find the radius, center, and thus the area of such a circle if we have the equation of the circle in this format. However, a circle's equation doesn't have to be in that format, and the SAT will present you with at least one problem where you will have to convert the circle's equation to this format before you can solve the problem. You'll have to know how to complete the square before you do this. Alright, the general form of a circle is ax squared plus bx plus ay plus cy plus d is equal to 0. So notice that the coefficients of x squared and y squared are equal. You can convert the general form of a circle into the form that gives you the center and radius by completing the square. So yes, you really do have to know how to complete the square, because otherwise you won't be able to do this problem. Example, what is the radius of a circle with the equation 3x squared minus 6x plus 3y plus 12y plus 14 equals 0? Notice this could easily ask the area of the circle, since once you figured out r, it's really easy to figure out pi r squared, which is the area. So first step, you're going to divide each term by 3. Why 3? Well, because 3 is going to be the greatest common factor of all these numbers except for the 14 here. Why the 14? Because it's a constant. We don't care about that. We'll see in a second. So all of a sudden we have x squared minus 2x plus y squared plus 4y, and then we have 14 over 3. So the second step is we're going to subtract the left side constant from each side, so we just have the x and the y terms on the left. So now we have x squared minus 2x plus y squared plus 4y is equal to negative 14 over 3, because we subtracted 14 over 3 from each side. So now we want the coefficients of x, so that's this negative 2 here, and y, this 4, and square them. So okay, half of negative 2 is negative 1. Square it, you get 1. So we're going to add 1. And then half of 4, of course, is 2. Square that, and we just back to 4. So we're going to add 1 and 4, which is 5. Or 5 is also 15 over 3. So we end up with x squared minus 2x plus y squared plus 4y plus 5 is equal to 1/3, because we're adding 15 over 3 to negative 14 over 3. So the fourth step is we're going to rewrite the x and y parts as the sum of two perfect squares. And by x and y parts, I mean anything with any power of x in it. So x squared minus 2x, x squared minus 2x plus 1 plus y squared plus 4y plus 4 equals 1/3. And then we can easily factor that to x minus 1 squared plus y plus 2 squared equals 1/3. If you don't understand how I got this, please review factoring. And I believe I have a video on that. So the center is 1, -2, and the radius is the square root of 1/3. So it's the square root of 1/3, which is the same as the square root of 3 divided by 3. That you're just rationalizing the denominator, so you're multiplying this by square root of 3 over square root of 3, so you end up with 3 on the bottom and square root of 3 on the top. That's called rationalizing the denominator. Please don't forget to do that. Mostly your math teachers will get angry with you and not give you full credit if you don't rationalize the denominator. The SAT generally wants you to rationalize the denominator, but it doesn't always. So if you don't see one form, try, if you don't see it with where it's not rationalized, where there's a radical in the denominator, try rationalizing the denominator and see if that's one of the answer choices. Either way, in this case, the area is pi times 1/3, which is, going to be pi over 3, because when you square the square root of 1/3, you just get 1/3, then you multiply by pi, so you get pi over 3. I'd like more practice, please. Okay, if you'd like more practice, there is quadratic equation-solving help at Khan Academy. Khan Academy is the official provider of video help, etc. for the College Board, who of course are the SAT people. So they're very good. Khan is a super nice guy. I believe he started just because he wanted to help his nephew with this and decided he wanted to help everybody in the world. So you can go to this address at Khan Academy. This was also in the information beneath here, and check it out. The quadratic formula, again, Khan Academy has got you covered here. And then there's a Cliff's Notes page. If you're my age, you probably use that for all the books you had to study in school, where you'd look at the Cliff Notes and use it as a supplement for studying. And that covers factoring, completing the square, and the quadratic formula. Very good page. And of course, the College Board has practice SATs available, which they have the full-length math sections. You can see everything that's likely to show up on the math sections. And they're good things to practice because they're from the official SAT people. All right. Did you find this video useful? If you did, please like it and subscribe to this channel. Neither action costs you anything. You'll be alerted about my new videos. You're not going to get spammed to death by YouTube. That's not how they operate. Why do I care? It's simple. YouTube doesn't let me share any ad revenue unless I have 1,000 subscribers and 4,000 hours of view time in a year. I mean, the 1,000 subscribers can come anytime, but I have to get 4,000 in a year before they'll monetize my videos. While many people are watching these, I don't have 4,000 hours of watch time, and I'm still short of 1,000 subscribers. Keep getting closer every day, thanks to everyone who subscribed, but right now I'm at about 650, so still need another 350. Alright, for the same reason, you are encouraged to share links to this video, put it in playlists, etc. You don't need my permission. Just please don't cut out the parts that credit me, or at least credit me somewhere if you use something that I wrote and directed. I'm always happy to read and respond to constructive criticism or suggestions for new videos. You don't like the music, you don't like the background, something else is bothering you about this, if you think I actually made a mistake on one of the videos, go ahead, let me know. If I made a mistake, I'll tell you I'm wrong. I reserve the right to delete comments from and block those who specialize in destructive criticism, more commonly known as trolls, or things that are off topic, which is people spamming whatever worthless stuff they're trying to sell, or just people who are a little disturbed, or a lot disturbed for that matter. Anyway, contact me. You can contact me on my cell phone, 415-623-4251. You can text me on my cell phone at the same number, of course. You can email me at john@johnlinnebaugh.com. You can mail me at 1859 Powell Street, number 109, San Francisco, California, 94133. Thank you very much for watching. Hope you're having a good day.